Hey, this is Leach with Simpson Math, and in this video, we are continuing to look at how to factor using the AC method. This is also part of a series of videos which will serve as a fundamental review of factoring geared towards the college algebra student. Now, if you haven't watched my previous videos about factoring, especially the one where I introduced the AC method, go check it out right now. What are you waiting on? Because in this one, I'm going to move a bit faster and we're going to show some different things. So if you're ready to go, let's get started by factoring 2x squared plus 7x minus 4. So again, like in the previous videos, let's go through our 6 steps. So first, it's written in order. Our GCF is good to go. It's 1. So now let's do the AC step. So let's multiply A times C. Now A is 2 and C is negative 4. Notice that difference? So A is 2 and C is negative 4. So when I multiply 2 times negative 4, what do we get? We get negative 8. So when we were writing our factor pairs, just write the factor pairs of 8, but we have to be mindful about getting negative 8 when we multiply. So let's now write our factor pairs of negative 8. So how do I get negative 8 when I multiply? Well, I could do a negative 1 times 8, or 1 times negative 8, or negative 2 times 4, or 2 times negative 4. So I have those 4 options. Now, I'm not going to bother writing all 4 of those down. I'm just going to be aware that one of the numbers need to be negative, not both. So if it's going to be a negative 8, one of the numbers need to be negative. Now, I'm looking for a sum of positive 7x. Since it's a sum of positive 7x, I actually already know that it's either going to be a negative 1 times 8 or a negative 2 times 4. I've eliminated the other 2 options. Why is that? Well, because if it's a positive 4, that means that the bigger of the 2 numbers, so the numbers here on the right, need to be positive. Right? Now, you might have had some previous teachers who went through all the details about what the different signs mean. At the end of the day, just think about, I need to make sure that when I multiply, I get this. When I add, I get that number, this B number here. So don't stress too much about it, but there are some patterns that will arise. So it's going to be a negative 1 and a positive 8. If you were to do a negative 2 and a positive 4, it would be a positive 2 when you added, which is not 7. So now that we have that, that's really all that's going to be different about this next thing. It's just the only thing that's new is really getting that factor pair. So now I'm going to replace 7x with negative 1 and positive 8. So negative 1x and positive 8x. So when I do, I'll end up with this. So I've done that. Okay, so now I need to do the factor by grouping. So from the first 2, I have just an x. From the second 2, I have, what's the sign right here? Positive 4. Yes, there are other negatives floating around, but it's whatever is the sign of this, as long as you have them written here in that correct order. So then I have that 4, and I have an 2x minus 1 left inside. They match like they should. So I get 2x minus 1. And then what's left inside is x plus 4. So really the only difference with this one is we have this, because it's a negative 8, because our C here was negative, then we had to deal with the different signs. Now I'm still looking for a sum. I don't want you thinking about a difference. Again, if you looked at did the product and sums page, you saw that you were just adding and just one of the numbers was negative. All right, for our last example in this video, we're going to find the roots of f of x that equals 16x squared minus 36x minus 10. So again, because we're finding the roots, step 1 of that is to replace f of x with 0. We're going to let f of x equal 0. So then we're going to find the x values that produce an output of 0. So 0 equals, and if 0 equals all the way down, and then we'll do that solving stuff at the end. All right, so look for GCF. They're already in order, so look for GCF. Well, our GCF, I see 16, 36, 10. They're all even, so that's good news. What about 4? 4 goes into 16, 4 goes into 36, 4 does not go into 10, so I'm probably going to, I'll call it a day at that one. And so GCF is 2. So then I have to pull out that GCF of 2. I'm just going to sneak that down there. There we go. So GCF of 2 is, so I pull that out and have left inside an 8, 18, and negative 5. I was a little flippant about that 2. I was like, yeah, sure, that's probably going to be fine. And then especially in this step, once you divide out that 2, and you are doing division there, we're just having it linger. You can just do a quick double check. 8, 18, they do have a 2 in common, but there's not a 2 in 5, so we're good, we're done. All right, so you can just check for that GCF one more time as I erase the entire problem. All right, so let's look for AC. So AC is, what's AC? What is A? What's C? I'm just testing to make sure that you know that AC is negative 40. We do not use this 2. It's a GCF out. It's dead to me. I'm not using it anymore. It's just going to follow me down, little lost puppy. So we have 8 times negative 5, which is that negative 40. That's where that came from. All right, so if you want to write the list, cool, or you can just think about it. I need 2 numbers that multiply to give me negative 40, but when I add them, I get a negative 18. So if you need to write the list, do that. If you don't, you could start maybe getting to the point that you're good to not write the list or do what I talked about. And you'd be like, oh, well, negative 40 works. I know negative 40, so let me just try a positive 4 and a negative 10. That's a negative 6, so I need to go up this list. So with this, I know, again, that the bigger number is going to be negative and the smaller number is going to be positive because when I add it together, this time I'm going to have a negative 18, so the bigger one has to be negative whenever I add them. But I have to have one negative, one positive in order to get that negative. So I end up with 2 plus negative 20 is negative 18. Those are the 2 that work. There we go. So then I break it apart, and I get 2x minus 20 when I break apart my negative 18x. And then we do our GCF process, our factor by grouping process. So there's a 2x that's in common with these first 2 terms. Again, I'm ignoring these 2's. So that 2x that I can pull out, and I'm left with a 4x plus 1. And then over here, and again, remember, this was part of my GCF video. 2x divided by 2x is 1. Always do that quick distribution double check. I've seen many a student who want to just not write that plus 1 and they just want to write 4x. But if you do your distribution double check, you realize that you then just lost that plus 2x. That's where we have to have that plus 1. All right, so then what is 20x, negative 20x rather, and negative 5 have in common? Well, they both have that leading negative, they have the negative, so I have to pull out that negative, but they both have a 5. So make sure we have that negative 5. And then again, 4x plus 1, as expected, because this is factorable. Then, again, I don't need these square brackets anymore once you move on to the next step, because it's all multiplication then. So I have this 2 times 4x plus 1, then a 2x minus 5 is left inside. All right, so now, remember, we're finding the roots. If we were factoring, just factoring, we'd be done, but I want to find the roots of this. So as we've seen in previous ones, I'm just going to set those equal to 0. But what do I do about that 2? So with this 2, there's a few things you could have done. So one, we could have, from this step right here, instead of factoring out a 2, I could have just divided both sides by 2. And if you didn't want to do it in that step, you could do it in this step right here. After you factored out the 2, you could then be like, okay, we'll divide by 2, but divide both sides by 2. 2 over 2 reduces to 1. 0 divided by 2 is just 0. And then literally, I can just erase those, erase these 2's from here on out, and then no more 2's. Now, why is that legal? You can divide out constants all you want. You are not allowed to divide out any of these numbers. So if I was to divide, like right here, divide both sides by 4x plus 1, divided by 4x plus 1, sure, that reduces to 1, and that goes to 0, but the problem is you just lost an answer. So you can't divide everything, both sides by everything when you have a, you can't divide everything by one of your factors that has an x in it, but you can if it's just a constant. So there's kind of two ways of dealing with it. You can either divide it out and make it go away so you no longer see it, or at this step, just don't worry about it and just set the factors with x's equal to 0. Or you could think x doesn't equal 0, 0 doesn't equal 2, so that's not one of our answers. That's another way of thinking about it. All right, so just get rid of the 2, we don't need it. So then set our factors equal to 0, 4x plus 1 equals 0, 2x minus 5 equals 0, and solve. Subtract the 1, divide by 4, add the 5, divide by 2, and write them in order, and in set notation. So x is the set of -1/4 and 5/2, and that's that. So if I plug in -1/4 and 5/2 into this answer right here, I would get 0. And those are also ways that you could double check your answers, is plug them in and see that you get 0. All right, so that's 2 examples where our AC ended up being negative because our C was negative. Join me in the next video where I'm going to just quickly go through 6 problems. I'm not even going to go through them step by step. I'm just going to point out some kind of surprises and some interesting little things that happen about them. None of them were even covered up. Just a quick gloss over 6 different problems so you can see just some sort of kind of differences or some surprises that you might encounter while factoring these trinomials.